Hello friends, in this video we will see vapor compression refrigeration cycle and effects of superheating and subcooling. VCRS cycle can be drawn on two diagrams, pressure versus enthalpy and temperature versus entropy. Let's see the cycle on pressure versus enthalpy diagram. So here is the saturation curve. Now assume point 1 is the initial state of refrigerant used, which is at low temperature and low pressure dry saturated vapor refrigerant. Now pass this refrigerant to the second point through a compressor, where its pressure as well as temperature both increases. Here enthalpy will also increase as it is the function of temperature, hence making an inclined line in the pH diagram from point 1 to 2, which shows that there is increment in pressure and enthalpy both. Now this high pressure high temperature vapor refrigerant will pass through a condenser, where the vapor refrigerant gets converted into liquid refrigerant by the rejection of latent heat at a constant pressure, hence drawing a constant pressure line up to the liquid saturation curve. After condenser, this high pressure high temperature liquid refrigerant will pass through a throttling device that is heart of this cycle, which is nothing but a capillary tube in which its pressure and temperature both decreases but enthalpy remains constant, hence drawing a vertical downward line from point 3. Now just pass this low pressure low temperature liquid refrigerant over the body where you have to absorb heat, most likely in the evaporator. During heat absorption process at constant pressure in the evaporator, refrigerant further evaporates and transforms into pure vapor by absorbing the latent heat of vaporization, where we get the refrigeration effect, and then passes to the compressor again, therefore drawing a constant pressure line up to the vapor saturation curve, like this. And this cycle repeats again and again to get the continuous refrigeration. Let's see the effect of superheating and subcooling of refrigerant in the VCRS system by using same pH chart. As we increases the temperature of refrigerant before entering the compressor, the state of refrigerant will become superheated. Hence, point 1 will come in superheated region, and this superheated refrigerant is compressed in the compressor. As in the compressor entropy remains constant, but in the pH chart the slope of constant entropy line decreases towards the rightward, like this. Then this phenomenon is known as superheating. Due to superheating, the refrigeration effect will increase, but work done required in the compressor will also increase. In short, output as well as input both increases. Hence we can't predict whether the COP will increase or decrease. The result will vary from refrigerant to refrigerant. While if we reduce the temperature of refrigerant before leaving the condenser like this, then this phenomenon is known as subcooling, which can be done easily by increasing the size of condenser only. Due to subcooling, the refrigeration effect will increase while keeping work required in the compressor same. In short, output will increase, keeping input constant. Hence, COP will sure increase in this case. So this was the basic concept behind superheating and subcooling of VCRS system. I hope you like this video. And if you want me to make a video on a particular topic, then you can tell me in the comment section below. Meanwhile, you can watch my complete playlist of refrigeration and air conditioning by clicking here. And finally, thanks for watching.